as you will notice here, we do have our motion diagrams, and there's something a little bit different about these. Nothing really too much, but you do actually see that I do have the letter X here. For these problems, initially what we're going to be doing for these kinematic formula problems, what we're going to deal with is actually having a car on the road, and it's going to go in a certain direction. And notice that this is along the x-axis, as opposed to being on the y-axis. That's the reason why we're using the x here, is because it's just describing the axis that we're working on, and that's the change in position. What I want to do here is, you should actually just be reviewing this, make sure that this makes sense to you. I know that was a horrible squiggle. I meant to do something like this. Bam, right there. All right, so this should actually make sense to you, considering that we went over motion diagrams in the previous lectures. Now, what I want to do right here is, I know that we're using yf minus yi over xf minus xi. Let's just do a little substitution. So this 80, what does this 80 represent? Well, that's the final position, right? And the final position, we're going to be denoting that to the letter x. So instead of using yf, I'm going to use xf, because once again, we're using this x here, and that's the final position of this object. Minus, and the 20 represents the initial position, which is once again denoted to this x. So this is the initial x position. Divide that by, in the denominator, we have the 3 minus 1. What does the 3 represent? Well, that's the time. That is the time in the final position, or the final time, I should actually say, minus the initial time. And once again, this represents our velocity. This is our average velocity. Another way to go about writing our TF minus TI, we're just going to write it like this. This is a triangle. This is called delta. This is a Greek symbol. The Greek symbol delta just represents the change in. So it's the change in amount of time. This is one of our kinematic formulas that we will be using. Now, once again, velocity, what is that? It's the change in position over a certain amount of time, which is exactly what we have represented here. This is our average velocity. Okay. Well, how else do you actually get an average? Think about this. Say if I have the numbers 3 and 5. How do I get the average of these two numbers? Oh, wait a minute. I could just add them and divide by 2. So we have 8 over 2, which is equal to 4. And that's the average. 4 is the average of 3 and 5. So, keeping this concept in mind, if I'm given an initial velocity and a final velocity, can't I just add these up, divide them by 2, and also get our average velocity? Well, yeah, you know what? And that's another kinematic formula right there. So these two formulas both describe how to calculate the average velocity.